All right, I think it is time to start. Welcome to the six-man working group session at IETF 111, the 111th IETF meeting, depending whether you count the first one or not. Let's see, next slide. This is the note well. Hold on. And you should note it well. It's an important part of the IETF process. And here's the information about the Jabber Room, Meet Echo, which I assume you found if you're here. Thank you to Shu Ping and Barbara Stark for taking minutes. We don't have an official Jabber scribe. We're not sure it's actually necessary anymore. And the presentations can be found in the data tracker at this URL, as usual. And we are using the Meet Echo speaker presentation feature, new feature this time, which means we don't need to share individual applications. We essentially uploaded them to Meet Echo before the session started. And we're going to try to have each speaker share the slides themselves and pick their presentation from the list, and then the speaker can advance the slides themselves. If this doesn't work, the chairs can share the slides. So when you should click on the share preloaded slides and select your presentation from the list, and they should all be there, we believe. Our agenda for today, we were only given a single session, so we have 2 hours. We have one working group draft to discuss, 4 active internet drafts, and 2 new internet drafts that we haven't seen too much discussion on. And at this point, I'll turn it over to Oli. Are there any questions about the agenda first? Okay, I'll turn it over to Oli.
If not, then we'll do the document status. Since the last IETF, we have published no RFCs, but we have gotten the gratuitous neighbor discovery document into the RFC editor queue. That has gone through 4 revisions since IETF 110. So it's quite a lot of activity after the working group has declared it's done with the document. We have 2 documents submitted to the ISG. It's the Spring, or the document we're working together with Spring on, which is the OIM document for segment routing, and it's the alternate marking method draft. They're both progressing at the ISG. The OIM document is awaiting for revised ID from the authors. I believe the alt mark one is it's in ISG evaluation for the last 5 days. So that's a little bit behind the other one, but that's moving forward. Next slide, please.
Oh, sorry, that's me.
Unfortunately, we can't share the controls. NOM is awaiting write-up. We have the longest adoption call in history. That's still stuck awaiting the Spring outcome. There was, for those of you who participated in the Spring meeting yesterday, you're probably more up to date than I am. We'll see what the outcome will be of that. We have 1 working group document. It's the minimum path MTU op-by-op option. That's next on the agenda. And we have 1 document that just expired, which is the robustness of Slack during flash renumbering events document. Any comments on document status before we move on to the path MTU presentation? No, then I think it's, is it you, Bob, or is it Gory who's going to present that?
Well, both of us, I'll run the slides. So now see if I can find it. There we go. There we go. So this is the IPv6 minimum path MTU hop option that Corey and I are authors. Corey, do you want to do the background? Can't hear you.
Yes. The background to this is the background to this is really that PathMTU doesn't work that well. It works okay if everything is implemented by RFCs, but things aren't, and ICMP messages don't really get through as much as you would need to make this reliable. So we have datagram packetization layer PathMTU discovery and PLP MTUD. And these two documents give us a much more robust way of operating, but they require probing through the network. So this option that we're presenting here is a way to find out from routers on your path a number that can then be probed and confirmed using PathMTU discovery using PLP MTUD. And this really helps if it's supported. If it's not supported, then it's simply ignored and other things will happen. So it's not a disaster to have a path that doesn't do the right thing, but if it does, then you get a great benefit and you avoid the black holing that currently occurs with PathMTU discovery. I tried to this slide. You can do this one.
Well, so this is the actual option format. It's very simple. It has, you know, the usual control bits at the front. You know, that if you don't recognize this, you can skip over it. And the option data, of course, can change en route. We have a temporary assignment from IANA for this option. There's a length field, and then there's two data fields, a minimum path MTU in octets, which the goal is for every router along the path will overwrite this field if it's the outgoing MTU is smaller than what the host put in. And then there's also the ability to return the path MTU field to send back to the source, and as well as a flag that allows you to the one side to request the other side send the result back. So we went through a couple of iterations of this, but we think this is about right. Yeah, so I can do this. So the basic operation is that routers compare the minimum path MTU field with the configured MTU of the outgoing link. If it's less, you rewrite it, and that going from source to destination should result in the minimum path MTU being delivered to the host. Host will originally fill in the minimum field with the MTU of the the configured MTU of their outgoing link for the packet. And you can set the return field to the cache value of the reported MTU, essentially the last one you've received. And you may also request that the destination host return the minimum path MTU by setting the R flag. And host receiving this, save the minimum path MTU for the flow, and if the R flag is set, include the minimum path in the next outgoing packet for the flow. And so that's the basic operation. The draft goes into, I think, a lot of detail about considerations for doing this, when to do it, which packets to put it in, but this is basically what this does. So I think this is, yeah, it's going to be a short presentation. We believe the document is stable. The current draft was limited to editorial changes. We have done some testing and implementation. Wireshark is shipping, so code in the production release that will display these. There was an IN, a temporary code point allocated. And so we would like to request working group last call on this. The current documents list the state as experimental. It could obviously be standards track, but I don't think we have a very strong feeling on that. But we would like to hear from you. So questions, comments?
Torlis is in the queue. Please go ahead.
Yeah, very nice. I haven't tracked that in before. Is there any experience from ECN? I don't remember what that was originally called, experimental or standard track. That seems to come closest to the last question, I think. Standards or experimental.
Corey, can you answer that?
Yeah. ECN as defined currently in 3168 is standards track. The new work we're doing in the IETF on L4S, which is a second generation ECN, is going to be experimental until it's been deployed and we have deployment experience. So I'm unfortunately unable to help on this. The first version was proposed standard. The second version of ECN is put forward as experimental. So I think it just depends.
Put in as standard, right? The original was it updated later?
The original, as currently existing as RFC, is standards track, okay. Proposed standard.
Yeah, I think that we could be consistent on that. But you chose experimental because you don't feel that strongly about the L4S stuff being all that well understood.
Okay, L4S was experimental because the original ECN appears to be more of an experiment, and we could talk at length of this. We think another revision of the specs would be good for L4S in the transport area, so L4S is experimental and will hopefully become proposed standard in a year or two. I don't mind for this particular 6-man option which one you choose. I mean, we should do whatever is consistent with 6-man normal working practice, I think.
Super. Thanks, Torlis. Jeff, you're next in the queue. We can't hear you yet. There we are.
Whenever you start proposing modifications to what is effectively a widely deployed protocol, you have to figure out that not everyone is going to do this overnight. And the mechanism that you're describing here appears to work effectively if every single router on the path actually supports that option, but they won't. And not in a million years will that happen. And so the real question is, how effective is this under partial deployment? And does the draft even argue what mitigations can take place if the information you get back is basically faulty because of partial deployment? Thanks.
Well, Jeff, thank you. The draft actually discusses this, and I think it's Gory and ours expectation that there will be mixed implementations of this for a while, and the draft argues that most any information you get is helpful to the transport. Do you want to talk about that more, Gory?
Yeah, I mean, this is not a replacement for path MTU discovery. It's another way of discovering something about what the path MTU might be. And the way in which I see this being most useful is when you have some routers on the path that you configured, and you're using the PLP MTUD version of the spec. The PLP MTUD needs hints to know what to probe for. This is a really good hint to probe for something. There's no way you'll ever know what a Ethernet switch or layer 2 device is going to do on your path, or what MTU that might have. So we can never have really good information. So the only really good information to prevent black holing is to probe. This provides a first guess at what to probe for. And in doing so, you can get much more quickly to the right value that is big enough to use the path effectively. So no, you don't need good information from every router on your path. And even if you had it, you wouldn't have good information about the path itself.
Thanks, Torles, and then Jen.
The one thing I would be worried about in general, and unfortunately I don't have practical experience much with IPv6, but is that, you know, routers, even if they don't understand the option, by pure having an extension header in packets that previously didn't have one, are punting these packets and therefore forwarding them slower, and that may create undesirable churn, right? So I'm not quite sure how to probe for this effectively on the internet, because I think, you know, the big risk of this is it's so attractive that, you know, people would want to put it over internet path. And so some thoughts about trying to do experiments, figuring out if there are performance impacts, thing that can be seen by a higher latency because of punting and so on. I think that would be really helpful to vet, you know, then also whether to make it for that reason experimental as opposed to standard.
Yeah, Torles. The draft suggests that you actually probe the path occasionally, like you would do with other path MTU probes. So you wouldn't add this to every packet. You would add it probably to a sacrificial packet that you know might be dropped, because some people drop packets with extension headers. So I would see very few packets carrying this if you want to use it to advantage. Just a few maybe at the start of the flow, maybe periodically as a keep alive function.
I think it's just purely, you know, what percentage of packets can reasonably be, let's say, punted, even if they, you know, there is no benefit from it, right? Because the routers are just punting and then figuring out, oh, I don't even support the feature. Right.
So I do think we have 2 more presentations after this, which goes on that topic a little bit. And there was also a presentation on, was it IETF 110 or 109, you know, when this document was presented with some experimental results as well. And we have updated 8200 to say that, you know, you should not punt for whatever that means in a particular platform. Jen, do you want to go ahead?
On the topic of packets being dropped, because I agree it's probably the biggest concern with the technology. So I read the draft, and that section mostly talking about, yeah, firewalls dropping it and sending ICMP, which I'm not sure really happening. And my question is, while draft is saying this is supposed to be used in data center and controlled environment, first of all, how does the host know that it should send this option for this destination, because this is in controlled environment and should not be using in internet in general? Because I'm afraid if host starts using it for all destinations, it might cause failures, especially as draft say you used in TCP SYN. So the SYN will be dropped, will be seeing more API balls failures as a result, right? I'm afraid, because your TCP connection over V6 wouldn't be established, and it would fall back for V4. So maybe the draft should talk more about fallback scenarios and how to prevent API balls failure and how to prevent the connection establishing failures, especially for internet destination. But yeah, I like the idea. Don't get me wrong.
Jen, thank you. That's a good comment. And I assume you're responsible for the seagulls in the background. Yeah, we had the first version of the draft, I think, had the notion of controlled environments, but I think that does need to get, I mean, that would be a very good last call comment that I think we could address.
So at least from my perspective, as the chair for this document, I think I think the next step here would be to last call the document and then eke out any of these issues. And I mean, you know, if we choose to publish it, it will, you know, this is probably the first hop by hop option that has a wide applicability, and it will have, you know, that set of marks coming with it, I think. But that might be, you know, if we choose to publish it, I think we might as well, as you know, as the authors declare they're done, you know, we should do the last call and then see what the result of that will be. Does anyone have any objections to me doing that, last calling this document after this meeting? If not, you have ample opportunity to say so during the last call.
Of course.
Excellent.
You want to last call it as experimental?
In its current status, yes. And then,
Okay.
you know, if we choose, that's a debate I think we can have during the last call as well, don't you think? You know, if we decide we want to, or even the ISG can change it at any time later. So, yeah.
Changing it later will mean a second IETF last call probably, but yeah.
Okay. Yeah. Let's try to make a good pick.
I mean, personally, I don't see any real problem with keeping it as experimental. I think that's fine. I mean, there is a degree of an experiment here, a long-term experiment here that's tied to, you know, hop-by-hop options in general.
Excellent.
I think someone once referred to IPv6 as a science experiment.
Well, wasn't IPv4 also one?
Of course. All right.
Excellent. Thank you very much. And could Bob and Gory please enter the stage down in the pink box and do the next presentation too?
All right. Well, the slide sharing thing is working quite well. So this is this was developed afterwards. Basically,
if we'd been really smart, we'd have done this one first. But we only discovered that we need to do this after we did the first one. Yeah, sorry, Bob. Go ahead.
No, I completely agree. So I guess I can do the introduction. I mean, so as I think is very well known, hop-by-hop options are not working very well on the internet. It's very common for routers to drop packets with hop-by-hop options. It's probably a great firewall feature. And so the conclusion here is we need to do something different. We expect hop-by-hop options to be useful in the future. And anything we do is not going to magically change the internet instantly. It's going to be a long-term thing. You know, routers and hosts will need to change. This is a long cycle, but you know, the question is, do we want to? This is an opportunity to do some things that we think will help this. You know, proposing to change how nodes do hop-by-hop option processing. So in the document, we talk about terminology to describe this. We mostly use fast and slow path. This is, I think, a topic for debate. I think Gory and I will be very happy to change this to something else if the working group can agree on it or something. But in the meantime, we'll use these words. But it's, you know, I don't think this is the key element in this document, but we just needed a way of talking about these ideas of, you know, there's a fast hardware, usually hardware-based processing path in routers, and then there's one that's, you know, more software-based, that's general purpose, where routing protocols run, and so forth. We want to distinguish those. And it obviously varies based on the router implementation. So I'll do the background slides and then let Gory talk. So So in the first IPv6 specification, you know, pop-out processing was required by all nodes. You know, we ran into a number of issues, inability to process at wire speed and hardware. Packets sent to the slow path would degrade router performance and could be used as a denial of service attack. Packets, you know, there was no limit on the number of hop-by-hop options, or as Tom will talk about later today, the size of the number of hop-by-hop options or extension header options, et cetera, et cetera. It was a nice idea at the beginning. In 8200, this was changed a bit, changed that you only had to do hop-by-hop options if you were configured to do so, and this essentially documented the current operational procedure, but didn't improve the processing of hop-by-hop options. And there was some ambiguity in the text in 8200 if this was talking about all hop-by-hop options or individual ones. I guess if you treat it as all, it's sort of the same, but it could have been a little more precise, I think. And well, Rory, do you want to pick up here?
Okay, I'll try. So hop options are still not practical. You can't really use them widely, unfortunately. Paths commonly drop all packets with hop-by-hop options. Not all routers do this, but somewhere along your path, you're likely to find at least one that does this. Multiple hop-by-hop options in the same packet make the problem worse. Makes it a bigger call on the processing, more complex to process. Probably was a big ask for people to do all of these all at the same time. They could be used as a DOS attack. Not that you'd ever want to do this, but some people might inject packets just to create fun for the routers. Make them run slow. You put them on the slow path, they really do make it into a slow router. So we need to avoid this slow path DOS vector. That's absolutely critical. And the approach to do this, we're suggesting, is to write a new RFC that changes behavior just a little, but in a significant way to refocus the way in which hop-by-hop options are processed. The goal is to redefine and make hop-by-hop options practical so that you can actually use a hop-by-hop option along your path to do something useful. The caveat being, we can't change the whole internet by writing one RFC. Be nice, but it doesn't work. So it likely won't work for all paths. It likely won't work for all routers, but we believe that methods can be defined, such as the path MTU option we talked about, but other methods as well that will benefit if packets are passed that have at least one hop-by-hop option. So let's try and make this push and write an RFC and try and make the rules simple enough that people can actually use them. Next slide. We wrote something and it was complicated and it had many parts to it because the problem is not simple. So we made lots of changes. Do we want to go through all these, Bob?
Maybe the important ones. Well,
okay.
Yeah, so
the most important is the second bullet. We need terminology, and it's clear from doing this that good terminology is lacking. And one of our area directors helpfully said we didn't choose the terminology right. It's probably true. So we need better terminology. For this, we will just accept other offers of better terminology. From the point of view of the hop-by-hop options, the key thing is that we would like to see only one hop-by-hop option as a common way of supporting the method. And we'd like to change the requirement so that one hop-by-hop option must be processed and additional hop-by-hop options may be processed based on local configuration. So quite a significant change in the emphasis of what you would have to implement if you're actually building a router. What else, Bob, do you want to highlight?
Yeah, so the other change we made, and this was all based on feedback we got from the first draft, was that the first draft basically proposed, only fast path processing. No, nothing goes to the slow path, period. Only one option, just fast path. But there was some pushback or other comments that said, having some ability for things like router alert might still be useful. So we changed, so this version of the draft talks about, you process at least one option, you may process more, but the one exception to fast path processing is the router alert, which sends the whole packet to the slow path. You will see when we get to an issue slide, that's, I think, still an open question, but we decided it was reasonable to keep it as a feature because it could allow other kinds of extensions in the future. So I think those were the biggest change in this current draft.
Do you want to have questions now? We have two people at the mic.
Yeah, sure.
Tom, do you want to go ahead?
So in some of the discussion on the list, especially about the second bullet, that hop-by-hop option must be processed, there was a lot of question whether or not that's practical, because we have a lot of deployed routers that may just ignore all the hop-by-hop options, which would actually be conformant with RFC 8200. Can you comment on that?
Yes, but let's hold that for a second because we have some issue slides, and that is clearly one of the issues. So, why don't we go to get into the issue section, and then we can do comments on that. I think it would be clearer.
Kirati, do you have a comment on this slide, or do you want to hang on for the rest of the presentation?
I can hang on.
Thanks.
Okay. So we have a couple of slides which we'll do really quickly, which is basically the summary of the proposal as in the current draft. It's that first hop-by-hop option must be processed in the fast path. Additional hop-by-hop options may be processed if configured, with the one exception being the router alert. Nodes creating packets with hop-by-hop option should include a single option. They may include more based on local configurations. Obviously, you'd want to only do that if you had some idea that the nodes along the path might process them. And if there are more than one hop-by-hop option in the option header, a node may skip the rest without actually looking at them, so actually not processing or verify them. Just skip over the hop-by-hop option header has a length in it, so you can do this without actually looking at what's inside. And if you can't process a particular option in the fast path, you must treat it as an unrecognized option. Okay, next slide. The other change was in the zero draft, we basically eliminated all ability to send an ICMP parameter problem. We got a bunch of comments on that, and so we changed it to that you may send an ICMP parameter problem. So the ability to do that is still there, but you're not required to do it as you are in 8200.
We have another comment coming in on this one. Dave, do you have a comment on the previous slide?
The notion that, well, it was on slide 8 or whatever was my comment. The notion that the first hop-by-hop option is special, because that's the one that's going to be processed and the ones aren't, means that if you start having more hop-by-hop options, then my expectation is everybody's going to put in their spec, this one must be first. And so once you have two specs that say this one must be first, what happens?
Okay, well, one of the approaches might be that you send two separate packets. So this rather depends on what you're going to use the hop-by-hop options for.
Yeah.
But sending two packets
that
may be the right way.
Answer, is that written in the document?
So one of it'll show up in the issue slides. We did recently realize from thinking about the draft that if you have hop by hop options that don't need to be in every packet, this approach works well. If you have an option that is required to be in every packet in the flow, then that's going to make it, if it's the first option, then it may, if nodes are just doing one, then the others aren't going to get processed, or if it's the second option, it may not be processed. So that is an issue we are raising as well.
Yeah, I think as long as you deal with that in the draft, then it may not be a showstopper. It's just a situation that I expect to come up. And so if you say, well, if you think you need to be first for some reason, then consider not being required in every packet, so that other ones, some language like that you mentioned, Gray, if there's a discussion of that in the document for people writing future hop-by-hop options, because I expect this will be an issue, and it's better to kind of preempt it with guidance now, assuming that we have it, so that we can get, or at least assuming we can get consensus on it. So thanks.
I completely agree.
Suresh, do you have a comment on that, or that particular slide, or do you want to hold to the end?
Just a follow-up comment to what Dave said. So it's not a future issue. We already had this issue for the connect option. So if you look at like 70%.
Your audio is very weak.
I'll just get back in line.
Yeah. See if you can get your audio better, Suresh, and get back in line. Torles, comment on this slide?
The must be processed. How about new first hop-by-hop options, right? Things that haven't been defined up to a certain point, right? I mean, changing existing behavior is always difficult, but for new ones, let's say, for example, that new MTU thingy, much easier, I think, to get the must accepted.
Yes, I agree. There is a section in the document about some criteria for new options, and this should certainly go there.
Now we have Suresh back in line. Go ahead. I think we still can't hear you, Suresh. It's very, at least I can't hear you. Warren, on this slide, please state your comment.
Yeah, I mean, I guess just sort of a reminder, I guess, that one of the reasons that a lot of people are not doing stuff like this on the fast path is because of the complexity and cost of doing so. And simply saying, you must be able to handle one of them without bounding the complexity doesn't really change that equation very much. And maybe you don't have to do 5 or 6 or 10 of them, but you still need to know how to handle the hop-by-hop option in the fast path. So you have to design and build the capability into the ASIC. You have to design and build it into the hardware. You don't have to loop the packet around 5 or 6 times, but you still have to know how to actually process that. So it's better than having many and saying you have to process all, but it doesn't remove the complexity, it just removes the performance.
Well, maybe it does help, because maybe you could have a configuration table of which ones you're willing to support, and you've only got one to do it. So you could do this a little bit more efficiently because you know where to look and there's only one of them, and you can match it against the table. Yeah,
I mean, 8200 and this draft also do talk about per option configuration, about whether they're supported and what to do if they're not. So I think options which are complicated or long or whatever are not going to be widely supported. I think that's the challenge for creating. Hop-by options need to have a compelling use, which is not something we're addressing here. It's hard to do that, but I think that's the reality.
And a final try on Suresh. Let's see if we can now hear
Yeah, thank
more
you.
slides.
Can you hear me now?
We can hear you.
Yeah, okay. So Chrome just keeps switching the microphone. So now I totally accept whatever Dave said about the first option thing, and it's not really new. Like when we tried the Connex option that Gori knows everything about, we had the same issue. We said, okay, we made it a should to put it as the first option, because at some point we know people are not going to look past X number of options, and most likely the X is going to be 1. So I think like, yeah, some text for this, like to say like, hey, don't do it on every packet, could be very useful. And the reference for that is RFC 7837. So if somebody wants to look at it.
Yeah. And unfortunately, I think the current number is 0. We're trying to change it to 1.
Yeah, one last comment on this slide. Kireti, please go ahead.
Kind of a meta comment. We're having a similar sort of belly gazing effort in MPLS, and we're looking at how we might want to change, what we do in the label stack, and especially we want to put some stuff after the label stack, and so then but before the actual payload. So it's very similar to this hop by hop processing. Not all of it is hop by hop, some of it is end to end. But the idea that when these drafts were written, or when these RFCs were written for MPLS as well as for IPv6, we had a very different, what we could do in the forwarding plane was very different, and what we can do today is quite different. So we need to update what we're doing, taking into account the much more powerful processing that we have and the much bigger requirements that we have. And the second thing is, if you do have multiple hop by hop or end to end things in the stack or after the stack, how much of it should be processed, how much of it must be processed, how much of it may be processed. If you can't process it, do you throw the packet away, and so on. I just want to bring this to this group because Ron and I have talked about hop by hop options in IPv6, but I see this parallel between them. So even for the terminology, do you want to talk about fast path, slow path? Do you want to talk about, how do you want to talk about capabilities? How much should be done or must be done? How much may be done? So there is, I think, some commonality, and I think it's worthwhile to, at least for the authors of these, we have a design team in the MPLS working group, to say, okay, here's some things that we do have in common. Here's something that are very specific to our particular way of doing things.
Good, thank you.
That's it from me, yeah.
Okay, so let me just do the, should I go ahead, Oli?
Yes, please. That was the mic cue.
Okay,
oh,
so
yeah.
Yeah, so this is just finishing up what's in the current draft. So the draft currently says, about router alert, the node should verify that the router alert contains a supported protocol. The router alert format says here's the thing you should be looking at. And so obviously if you can't do that in the slow path, then don't send it to the slow path. And so only verified packets should be sent to the slow path. I think this helps a little bit. And obviously if you're going to do router alert processing, you must protect yourself from infrastructure attacks. It's, we're trying to, if we're going to keep this. And so with that, I'll, unless there's a comment on this, I'll go to the next slide, which sort of covers that as well. Oh.
So we do have 2 people in the queue. Perhaps we should slot them in now. Eduard, do you want to go?
Do you hear me?
Yes.
Yes.
Okay, I have a clarification question. I'm just trying to understand. If some particular vendor will implement 6, for example, options in fast path, but just 1 option in slow path, for example, just a situation, yeah? And because from this draft, it will have must, and 1 option is not implemented as a must, does it mean that this vendor is not qualified as properly supporting IPv6? Does this vendor could claim that he supports RFC, primary IPv6 RFC? What would be the consequences if one particular vendor will implement just 1 or 2 small number of options in the slow path?
Well, we continue the notion that, that a router will have a configuration table for which options it does in the fast path. And obviously you can set that so you do none, and I would think that would be compliant with this. I mean, the other thing about this is proposal that would be, if it goes, once it gets through the whole, if it gets through the whole process, I shouldn't say when, I know better than that, that it's going to be proposed standard. So while it updates 8200, it's, 8200 is the full standard. So it's, this would have, we're not, this does not change 8200. You can still be compliant with 8200 by not do this. It doesn't change that. But this is intended over a long period of time to be adopted.
But in this case, it means that a couple of slides before, the statement was wrong. It's effectively not the requirement that you must support something. It's a requirement to disclose. And disclose is a different requirement.
These are PowerPoint slides. This is not the draft. The draft talks about this. So it talks about configuration of individual options. So I think, and if that text is not sufficient, we will certainly change it. But yeah, we do understand this. So this does not by itself make, an implementation non-compliant with 8200.
Because there is a difference between must support and must disclose support. There is a difference. Looks like you're talking about must disclose support. Then yes, okay, understood. Yeah, sorry, thank you.
I don't know what must disclose support means.
Disclose
I think the answer to this is simply believe the beginning of the slide deck. We really want to get the right words in here. We really want the right terminology. This doesn't change the IPv6 core spec. It's something in addition that we hope will make things work. And we'd love to get more feedback on the wording. Really, we've thought a lot about the musts and shoulds. And if you start a discussion with us, we'll happily look again at any of them.
Okay, sorry.
Thanks. So I think we'll just continue through the microphone queue. I don't think it's a catastrophe if we don't get through all the slides. The discussion is more important. So Adrian, please go ahead.
Yeah, thanks. I sort of understand the dance you're doing with Router Alert, especially because there are protocols out there that use it. But I wanted to make sure you had read and digested RFC 6398, which, I know there's only 9,000 odd RFCs out there, and I don't know why you don't know them all by heart. 6398 basically recommends against wide use of Router Alert, and in particular against using it in new protocols. So in that context, maybe what you are doing here is only looking to support existing uses, and you can make your dance a little bit more precise.
Good idea.
Well, yeah, and we did read that one. Yeah, I think we're just anxious to call out Router Alerts as doing something different, but doing it different by a set of rules, not just doing it different because some things are not FastPath.
Yeah. Torles?
To jump onto what Adrian said, and I also read that. I know all the 9,000 RFCs. So my conclusion, I've repeated that on a couple of mail threads to this, is that if you want to do better Router Alert functionality, even in the spirit of Router Alert, I think we should have a new hop by hop extension header code point for it, and just leave the existing one as it is. And that kind of is similar to also the must for new stuff, right? Don't touch the existing stuff. And then basically see exactly these fast pass and slow pass things with very explicit mandatory requirements being brought into the individual extension headers. And then basically see if we can align what they do with this generic draft, right? In terms of saying, can we hold on this draft a little bit longer before finalizing it, so that we take experience from parallel happening new extension header proposals into account, right? If we don't have any good new extension header proposals, I think it's going to be very hard to make generic requirements in this document and have them be, well enough vetted.
Okay, thank you. Ron?
To add some color to something that Adrian just said. He said there are very few protocols that use the IPv6 router alert option. Well, actually, there's exactly one protocol that uses MLD. And given that we have a RFC discouraging its use, it might be a good idea to deprecate router alert with some caveat. It's okay for MLD to continue using it. However, a router need not support it if it does not support MLD.
Yeah, that makes sense to me anyway. I mean, the thing we talk about here about having configuration for the protocol in router alert would help with that, but yeah. I think deprecating router alert is probably not something we want to do in this document. But I thought the idea of creating a new version of it makes sense.
No, clearly not in this document, probably a different one.
Thanks.
Yeah.
Kireti, do you want to step up to the mic, please?
Quick, I want to maybe re-emphasize what Ron and Adrian before him kind of said, but I want to say it maybe a bit stronger. Don't let trying to make router alert work ruin what you're really trying to do here, which is trying to make hop-by-hop options work. So by trying to cater, doing the dance, as Adrian put it, the router alert dance, you're actually maybe making it harder for people to say, yeah, this is an important thing and let's do it right. So my advice would be, don't talk about router alert, fix router alert elsewhere, and just focus on making hop-by-hop work.
Okay. Thank you.
Torles.
Yeah, actually, I mean, in multicast, we had two other protocols that were using and still, supposedly on the functionality use router alert, right? One is PGM, which basically whose deployment got pretty much killed by exactly that router alert implementation issue. So that's why we got very annoyed about the, insufficient specification of router alert to, mandate fastpath or so. And the other one is RSVP, right? And in RSVP, in the meantime, as Kiriti was pointing out, we have much better hardware. So, there are 100 gigabit and faster, fast path processing of similar functionality as RSVP to set up flow state. So that would obviously be exactly something good for a new hop-by-hop option to do. So yeah, maybe it will end up being, that we're obsoleting all the old uses because router alert simply, got, badly specified, badly implemented, and we've got to let go of it.
Okay, thank you. So
then I think you're free to continue.
Thank you. A lot of the next slides we've been talking about, but so there is a section in the document about new hop-by-hop options. So we had some ideas of this, but I think in this discussion, I think this section will get expanded because I think there's more to it. But I guess the other way I would say this is any hop-by-hop option that is going to be used or implemented widely has to be it has to solve a compelling problem, because otherwise I doubt people are going to do it in the fast path. So this will always be a challenge. Okay, next slide. So this is a summary of the issues that were raised on the mailing list after we published the draft. I think many of these we've addressed, but feel free to jump in. There's the question of what terminology to use in the draft. I don't think it's an objection to describing it. I think what is the best word. So we don't want to get too caught up on that, but we're quite welcome looking for someone to tell us what's the best thing to use if you can get agreement on it. Then one big issue I think that was raised and caused there to be a lot of comments because the document is not completely clear. Is it the node must examine at least one hop-by-hop option in the fast path, or is it if a node is configured to process hop-by options, the node must examine, at least one option in the fast path? We could take comments on that now or later, or I can probably argue both ways.
Kireti, please go ahead.
Back to what we were discussing in MPLS, a very big part of this is dealing with legacy routers. And so I like the second way of putting this because it seems a little friendlier for existing routers. You just don't configure them to process them.
Right. Yeah, that I think is the common practice today. All right. And then the next one on the slide is, which we've discussed a fair amount in this session already, is, should we keep router alert as the exception, or would it be better that this is just the only fast path processing and nothing gets ever sent to the slow path? That was where we were in the first version of this document. But, there was some argument to be made that this might be valuable to keep. So, a couple of comments.
Kireti, please go ahead.
I would keep slow path processing, but I would dump router alert. I don't know what new things will show up in the future, but the option to be able to do something in the slow path might be useful.
Okay.
Thomas?
Why not specify in this document that any, new hop-by-hop header needs to specify explicitly whether it is fast pass or slow pass? Why, put it up here and for all?
Okay. Tom?
So we need to clearly denote which options are fast path and slow path. I look at this from a host perspective. The choice to send something that might go into slow path would be very carefully considered. It really does cause a lot of problems when packets of a flow take the slow path.
Right. We certainly agree with that.
So I believe we are now 8 minutes over time. So Bobby, do you want to go through, Bob and Gori, do you want to go through the rest of the issues, or do you feel you have enough for the next update?
Let's go through the slides, and I don't think it'll take too long. There was a question about the relationship between OPSEC, IPv6 extension header filtering. This is an informational draft in v6 ops. If what we're proposing is adopted, I think we should probably talk to v6 ops about the relationship. And question about, which we somewhat talked about, can existing deployed equipment implement this proposal? Probably not. I think this is really focused on revised equipment, updated equipment, which does happen. We're not expecting publishing an RFC is going to change the deployed base. And then the thing we just talked about that Dave raised, any hop-by-hop option that needs to be in every packet in the flow. If it's the first option, other options may not be supported. If it's the second, it may not be supported. We need text in the, new option or criteria for hop-by-hop options. Okay. And then there were some options or issues raised, which I think are not specific to this. we put our good points. You know, any service that uses hop-by-hop options, you know, it needs to work even if packets without hop-by-hop options are delivered. So something that, you know, if you can't, if they're not processed, then it's not going to work. Well, it's not going to work in today's world and probably even the future world. You have to use this to supplement what you're doing. And then there's a question about overall limits on the number and size of extension headers, including hop-by-hop, and I think Tom is going to be talking about that later today. Okay, and last slide. So thank you all for feedback. Gory and I think Six-Man should adopt this as a working group document. Our take is there is interest in working on this. You know, this is a question for adoption. It's not, you know, we expect the document to change considerably, perhaps, based on working group feedback. But we think we can work through the issues on the mailing list once it's adopted. And we sort of, to state the contrary, if we don't want to do this, you know, is our hop-by-hop options going to be ever useful? And as an alternative, might we just want to deprecate them? So that's, I think, where we finish up.
Excellent. Thank you, Bob and Gory. It sounds like the next step here is to do a call for adoption on this document. I'll put that on the list of action items from this meeting. If no one disagrees very violently with that, they can, of course, do that on the mailing list too.
During
Excellent.
the adoption call.
As well, indeed. Well, if they disagree with the adoption call, it was a bit late to hear it, but yes. We are still working on extension headers. So, Tom, you're up next. Let's see. Well, okay, you shouldn't request sharing your screen. You should share the pre-shared slides, if you can find that button on the top left there.
I don't see an icon for that.
Share preloaded slides. It's just beside the share screen button.
It just says ask to share slides.
Yes, ask to share slides is probably good.
Okay.
Let's see what happens. Yeah, and then you pick your slide set from the list. Excellent. Go ahead.
Okay. So my name is Tom Herbert. I'm going to talk about limits, some of these extension header limits that Bob actually referred to. That was actually quite a nice setup, so I can probably streamline some of this. The problem, I think, was already articulated. So extension headers have not been doing well. And a major reason for that is kind of what we were talking about before. Processing TLVs, processing variable length headers is hard to do, especially in hardware. And as Bob mentioned, one of the problems, or this problem was exacerbated by the fact that when we defined extension headers in RFC 2460 and 8200, we really didn't put any limits on them. So I agree with the consensus from the last set of authors. We need to do something to save extension headers. So the solution that I'm going to outline today, we want to specify some limits. Practical limits that may be applied to that extension headers. And there's really two goals to this. One is we want to make them practical so that we can actually efficiently implement them. But on the other hand, we don't want to restrict the functionality so much that their extension headers become pretty much useless. There's quite a bit of related work. So we have some measurements, also RFC 7045 mentioned some arguments about why routers are dropping them. There's RFC 883, some ICMP errors for drops. But I would point out RFC 8504 host requirements actually does mention some specific extension header limits applied to host receiving. So in some sense, we're expanding on that. And I would also say that the hop-by-hop options processing that we just saw is probably a subset of this. This draft more addresses the larger problem with hop-by-hop options. This is just a little bit of background. So we do want to apply the robustness principle to limits. So when we send, be conservative, liberal in what you receive. But I think there is one important consideration that we have to make, especially when we're sending. If we know that the paths we're sending into can actually support something greater than the default limits, particularly this is going to be relevant when we're sending into a limited domain, then we can actually apply higher limits. And that's going to be critical. So in other words, we're not going to define just a baseline set of limits that are strictly applied in all use cases across the internet. We want to allow for, if you know what your path is like, if you know your environment, you can actually do more and have more flexibility. There are two fundamental types of limits described here. One is limits on the processing of extension headers themselves. So that would include size of extension headers, number of them, number of options, length of options. But the other one is a limit on the length of the IPv6 header chain itself. And that's relevant for a very particular reason in deployment that I'll get to in a moment. So as I mentioned, limits on processing of extension headers, really it's a lot of parameters. So this can also go down into options, like how many padding options can be in destination hop-by-hop options, number of options, as I mentioned. So an example of that would be the previous draft we talked about. The limit would be one, the limit described there. So one hop-by-hop option. The IPv6 header chain length limit is really motivated by a common practice in routers that we did talk about extensively in v6 ops. This is the fact that a lot of routers parse into the transport layer of a packet to do their work. And in some cases, if they're unable to parse into the transport layer, they may in fact drop the packet. And the problem is that routers that do this often have very limited capabilities. Usually they can only process the first n bytes of the packet, which would be a hardware parsing buffer. And what we found is if the transport layer is too deep in the packet, then these routers and devices can't get to that, can't read that information, so they don't see the transport layer, and in some cases they arbitrarily drop the packet because they have this limited capability. Another important consideration is public internet versus limited domains. So kind of a simple rule when we're applying this, our robustness principle, if we're sending to an anonymous destination, the public internet, apply the most restrictive limits. When we're sending into a limited domain, limits can be relaxed. One important thing about that is a lot of extension headers, some of the extension headers, some hop-by-hop options, I guess some destination options, really are intended only for limited domains, which means having kind of global limits should not affect this. So for instance, segment routing would almost certainly exceed any limit that we could say that we want to send into the internet in terms of number of bytes in an IP header length chain. However, when you're sending segment routing, that's probably in limited domain. The expectation is that all of your devices in that domain would be able to accept the larger limits that are being applied. So the types of the application of limits is important. So we have one case of sending limits, only the host sends extension headers. And then we have to consider 3 dimensions of receivers. And for each of these, we can apply limits. And then an important question is for each of these senders or receivers, what is the behavior when the limit is exceeded? So for host sending extension headers, this is just simply, here's the limits that the host is allowed to send. So they can send packets with 5 bytes or some number of bytes of extension headers, some number of hop-by-hop options. Sending limits are typical like that. And then in the receiving case, we consider the host receiving. So again, this was kind of covered by RFC 8504, I believe. So host must process all extension headers and options, we're assuming that. The behavior when a limit is exceeded that the host applies would be to drop the packet. A router, on the other hand, is an intermediate node, never a destination. So really limits primarily apply to hop-by-hop options. The behavior that we expect there is to ignore data beyond the limit. So this also correlates to RC8200, where routers can ignore all hop-by-hop options. The important distinction here is that we don't want routers to drop packets with hop-by-hop options that they don't understand or can't process. We really want them to ignore them and pass them on, because even if the hop-by-hop option is not useful to them, it may be useful to another router. And if we drop packets, obviously, with hop-by-hop options at all, then the whole mechanism becomes kind of useless. Intermediate destinations are kind of tricky. These are the intermediate destinations that would appear in the routing list or routing header. And they actually have kind of attributes of both host and routers. So the rule of the behavior that is in the draft is if a limit applied to a hop-by-hop option or hop-by-hop extension header is exceeded, then we take on the routing behavior. So the extension header or the options are ignored. However, if there's a destination option before the routing header that exceeds a limit being applied by an intermediate destination, we would basically drop the packet. The rationale is that a destination is actually explicitly addressed by the sender. So it is the sender's intent that these options be processed by those explicit destinations. So I can give a little more detail about the limits. So on the host side for sending, we restrict padding that can be used, restrict the number of options. These are all kind of default, which means if I'm sending to a destination and I have no other information, then I would apply these limits. One of the more important ones is the next slide. This is the header chain limit that I mentioned. So the draft specifies this as a host must not send a packet with a length of the extension header chain greater than 104 bytes. And this is derived from the fact that we expect that routers and devices intermediate nodes should at least support 128 bytes minimal parsing buffer, which means they should be able to process at least 128 bytes of headers. There is some evidence that suggests that's commonly supported. We do have anecdotal information. I don't think anyone's ever done an actual measurement on the internet. But I would also point out less than that, if we don't have at least 128 bytes, extension headers probably aren't viable at all. So this is kind of a hard limit that we would want to make a requirement. And again, the problem isn't so much that if we have these large headers that we can't process the extension headers themselves. The problem again is large headers could push transport layer too deep in the packet such that routers that need that information can't get to it. So fundamentally, if you add all this up, it allows 64 bytes for extension headers. And again, this is a default, not necessarily a global limit if we apply it to limited domains. So receiving limits, go ahead.
Do you want to take a question now? We have Jen in the microphone queue.
Yes, Jen, go ahead.
So draft actually saying the host must not send unless it has explicit knowledge that recipient would accept it, right? So I'm just curious, because we don't talk about exact mechanism for the host to know that. And let's say in the future, we can imagine some kind of probing mechanism. In this case, host might send something just to discover that. So how about changing it to should?
Can we defer that? I do have some comments on that in a couple of slides. Thank you. So receiving limits, these are kind of similar to the sending limits. And again, already, those are basically based on RC8504. We just extended that. So for instance, a number of non-padding destination options and hop-by-hop options would default to 8. And then maximum lengths of headers, maximum lengths of number of options, limits on the IPv6 header chain length. A couple of notes about the receive limits. Let's see, so receive limits obviously should always be greater than or equal to the minimal sending limits. So it probably doesn't make a lot of sense if our receive limits are less than the sending limits. And then one way to view the number of hop-by-hop options, and this correlates with the previous draft we discussed. So we have a limit here which basically says that a router can process some number of options, basically 0 to the number of options in a packet. So in this draft, we say that the requirement is that a device can process between 0 up to the number of options. If they process something less than the number of options but greater than 0, then we expect it to be the first consecutive n options that they would process. So RFC 2460 basically specifies that n equals all the options. So we said that all routers must process all options, all hop-by-hop options. RFC 8200 changed that either n can be 0 or it's a little ambiguous, but apparently I think it interprets that either you can process 0 of them or all of them. And then in the last draft, we talked about basically that makes n greater than 1, so at least one option would need to be processed. So with that, I guess we'll have some questions.
Torles, please go ahead.
More like a comment. So I take it 50-50, right? So I think the analysis of what is likely feasible in specific contexts or so, I think is really great, analysis and information for people trying to build, extension headers and combinations of extension headers that hopefully could be deployed in, limited domains. On the other hand, putting any of this analysis into recommendations in the form of must and should or so, I'd be very scared about doing that right now, given how we have such a wide range of different type of devices, right? Data center devices are totally different than, metropolitan routers, than IoT routers, and so on, right? And I think the one thing that is just, as Jennifer was saying, if we do have a control plane, that can figure out what a particular path can do and orchestrate this stuff, then I think why do we want to have any generic limitations? And maybe, we should rather start from having, better understanding of what, may be possible. And then, for the deployment say, well, your control plane must, be able to tell you what can be done, what you can do there.
So yeah, I would agree with that, and then also I need to comment on Jen's point. But if you read the draft, we are very careful to place few absolute requirements. In fact, the only must on the receive side that we specify is that devices have to be able to process at least 128 bytes or 104 byte packet header chains. So all of the other limits are fairly unspecified. And with something like hop-by-hop options, I do like RFC 8200. Basically, a node can completely ignore them and still be conformant. And one of the things that's important, to understand is there's no such thing as 100% support on the internet for pretty much anything. The ability to poll or the ability to use a mashup map of the internet capabilities, or if I know I'm in a restricted domain, that's significant information, right? And I think that should be part of it. I would be a little, so on the public internet, I think the problem is a little tricky, because in order to make extension headers useful on the public internet, I think we really need to get to a baseline. The public internet has to be able to support something, a very, very minimal set. And that's what we're trying to do here. Within the limited domain, we definitely have a lot more flexibility, though. So I would agree with you. Having that measurements, being able to do the happy eyeballs of extension headers, what have you, that would be extremely helpful. And I think that would be the thing that, like the draft says, if you have explicit knowledge of the path beyond the defaults, you can actually use more of the capabilities.
Thanks. Dave, you're next in the queue.
I have two related questions. So I'll ask the first question, and then I'll have a follow-up based on the answer to this one. So you talked about how the primary problem you're trying to solve was where routers and intermediate nodes need to deal with things in the transport header, and they need to be able to find that transport header. My question, the first question I should say, is do you consider IPsec a transport header? In other words, is there any problem with routers that try to find things past that? Especially, the first question, let me take it into the encrypted case. Is there any known problems with hosts having destination options? There's a large number of them encrypted inside the end-to-end ESP session. And if so, what are those issues with hosts? In other words, why would you want to say that the sending node can't do stuff by default when it's end-to-end and it's never going to be seen by intermediate nodes because it's inside end-to-end IPsec, for example? So that's my first question. Or can you constrain this to say we're only talking about stuff that appears outside of, before an IPsec header?
That's an interesting question. I think the first part really relates to the fact that those routers that are looking for transport headers can't always find one.
Exactly. So the first case is you're guaranteed to not be able to find anything. Is there any problem with putting a lot of extension headers after that because it's end-to-end encrypted? Is the only problem you're trying to solve for routers, or are you trying to solve any problem for end hosts? And if you're trying to solve a problem for end hosts, do you have any evidence that there is a problem?
So for the first question, I don't know. I mean, the evidence suggests that there are routers that kind of demand to be able to have a transport layer. I don't know what they would do in the presence of an IPsec header. Maybe we should, maybe that's a question for P6 ops.
Yeah, I mean,
but for the second
my
one,
recommendation would be, it would be a lot easier to discuss if you said this is only for stuff that appears before an IPsec header, and anything after that, that's up to the end and host problem, because that's just, it's not addressing the problem you're trying to solve here. So that's my recommendation on my first question.
that would be fine. I think the counter argument would be IPsec isn't all that prevalent on the internet, so it might not change the base characteristics. But to answer your second question,
yeah, the second question I have not actually asked yet. That was actually variation of the second.
Oh, I thought you wanted to know about putting destination options into on the IPsec header and the effect that would have on the host.
Sure, if you want to keep commenting on that. Yeah, go ahead.
So limits are still relevant to the host, and we did that in RFC 8504 because we don't want hosts to be subject to the same sort of denial of service attacks. So we do want to have some sort of limits even applied to the host side for things like destination options.
We should be very judicious with anything that would affect the node requirements, RFC, I guess is my point there. My second follow-up question would be, especially if you're going to ask V6 ops or whatever about routers, then the same question comes up when you're talking about just AH or ESP null. In other words, it's not encrypted, but you can't parse past it the normal way. And so it would only affect routers if routers were trying to be super intelligent and be able to parse past IPsec headers when you don't actually have encryption. And there is a transport header later on. Is that a problem? Because that, I think, is probably a little bit of higher risk where you might be trying to address that problem, but only if there's routers that do that. So,
well, you can also throw in fragments to that list, right? So first fragment has headers.
That's that question too. Yeah.
So yes, this and this is a discussion we've had on V6 ops. The implicit requirement right now from some is that routers have to be able to parse into the transport layer. And we point out not all packets have a transport layer that's parsable. I don't know what that means. Relative to this specification, I think it's somewhat agnostic. But yes, I think in the real world, that's a definite issue. It also means that this is probably another reason why we can't deploy certain extension headers. We can't deploy IPsec if it's required that the transport layer is readable. That's a problem.
Yeah. But I'm just considering if there is a case where IPsec is working, right? I think it would be great to not break it. In other words, if there's something that's working today on the internet, don't tell host to change the behavior that would break something that's currently working. I get the fact that the IPsec wouldn't always work, right? But if you do have a situation where it is working across some network or some path or whatever, it'd be great to not break things that are currently working. So thanks.
Well, that could only be, so in this model, that could only be an issue on the host, because we want the requirement to be that router never drops packets because they can't process something.
Thank you. Excellent. How are you? Sorry for pronouncing your name wrong. Go ahead.
Yeah, I have a comment that I agree that there should be some limitation on the header size, but I just feel the harder limitation for the 104 bytes might be too rigid, because we cannot foresee what a future hardware can actually support. So it looks like the header buffer size is a fundamental parameter, just like the MTU. I'm wondering if there will be some mechanism actually to query or advertise such capabilities to routers, so the router or the host can decide how many headers they can support actually in the packet. That's some comment.
I think that would go back to what I call the happy eyeballs for extension headers. So a host that wants to figure out if it can use something beyond the limit could do some sort of query polling, basically send packets with larger extension header chains and see if they're received. So there would be some sort of mechanism to detect that. But the other point that I would make is the limits that we're defining really should be considered the baseline minimal limits. And like any other sort of limits, manifest limits that we apply, they may be applicable today, but tomorrow they may not be. Hopefully in our case, the potential limits would only get bigger, not smaller. If they get smaller, then we have a problem. So if we define the minimal today, and hopefully have a path where devices, nodes could detect when they're allowed to go beyond the limit, hopefully that would be sufficient for the problem.
Thanks, Tom. I saw our esteemed AD had a question put out on Jabber. Eric, would you like to post that here and see if...
Sure, hopefully one is working. If we do decide to say something sensible about hop-by-hop option processing, should the same document include this some sensible recommendations about limits, and I suppose vice versa? Does it make sense to have one document without the other? Does it make sense to have the two documents together in one?
I guess I'll start. I think they are related and potentially a subset. One is a subset of the other.
Yeah, we don't, in the processing, top-hat processing document, we sort of mention they shouldn't be too big, but we certainly don't specify sizes, but the limiting it to one or some number probably reduces that as an issue for hop-by-hop options, but there is some relationship between the two drafts.
Thomas?
Yeah. I think the fundamental difference is the requirement in the prior draft that at least one hop-by-hop option must be processed is probably the biggest difference.
I think the question is always what we're trying to achieve with a particular document, right? So any new hop-by-hop extension header that people like in functionality can always override what any of these generic documents are saying. But I think the biggest benefit of the generic documents is trying to figure out, a new common lowest baseline for hardware developers, right? So to make sure that they try to get up to that. And so if we kind of agree on what the goals are, I think it's a lot easier to figure out what we need to say about that.
So I would completely agree with that. I think that's the biggest thing that's been missing, is some sort of guidance to the hardware developers, especially in reference to the reality of deployment, as opposed to what the specification says, which as we mentioned are so unlimited, it's really hard to make a practical implementation without some sort of guidance.
Okay.
Okay, super. Thank you. Sorry. Were you about to say something, Bob?
No.
No.
So I
Excellent.
think you are next.
I think that concluded the section on extension headers and hop by hop. I'm sure the next steps for these documents is to continue work on the mailing list. Okay, so I'll be very quick. Let's see. So this has been presented before. This is a document that Tim and I have written about a universal configuration information option. Since IETF 109, we have added a section and a mapping table to support integer keys as well as string keys. That was based on a suggestion by Dave Taylor. There are other works and uses of CBOR in the IETF that uses integer keys, so this is also more consistent with that usage. It saves a lot of space is the main reason for that. So again, this document, the problem we're trying to solve with this document is twofold. It's one of process, where the working group has spent lots of time on various configuration information options, in 6-man for router advertisements and in the DHCP for various DHCP options. And what we're trying to do here is see if defining a self-describing option format based on JSON and CDDL and CBOR, that's encoded in CBOR, if we can then do almost get away with just having an IANA registry defining the options, and also implementations could just support the infrastructure here, so you could add a new configuration option on the router without having to get your vendor to change the implementation. And it's also started out as experimental, largely because of the process issues, to see if it would be beneficial to bypass quite a lot or simplify lots of the IETF process, because the IETF for the working group would take a year or even years to define a new option that perhaps it was quite trivial to start out with. So the format again is just a TLV, where the V is a CBOR encoded CDDL described object. It can look something like this. The new things we've done is to add a set of ranges. So these ranges are based on how efficient CBOR are at encoding these integers. So -23 to 23 is, I guess, a single byte, and then the next 16 bits are two. Well, I can't exactly remember how many bytes it uses, and then when you use different IANA actions for the different ones as well, depending on how valuable they are. But it's still the same first come first serve IANA registry with expert review. Then we added to the document a mapping table, so that the string keys have corresponding integer keys, and I did a little bit of comparison. We go down from 42 bytes to 29 bytes to send a PIO option, for example, with integer encoding. So it's quite a lot more efficient. One benefit also of using CBOR is, of course, that it's a much more flexible encoding that allows you not to include a default, fields that have default values, for example, which in this particular case made it more efficient than the RFC 4861 definition. So that's the question. So now we've been this draft, and apologies for that, it's mainly been me that have been slow on this, but this draft has now been around for quite a while. So I think we have, asked the working group to make a decision if it wants to work on it and take it to publication, or if we should abandon it. Any comments now, or otherwise we can take that to the mailing list.
Okay,
You want to run the mic queue?
Yeah. Yes. So Jen, go ahead.
Idea. Sorry, I can't recall if we discussed it before. So do you think it should be some place, maybe in this document, when you say what host is supposed to do if it gets conflicting information and this option and a standard array option?
So this is a point that Suresh also brought up the previous time we presented this document. So we have added text in the draft for that, but it might just be saying that that's a configuration error. I don't think at least we haven't come up with a sensible way to deal with that if there is conflicting information. The same thing applies between RAs and DHCP too, right? That if we have, I think we left that up to the implementation to deal with. But yeah, contributions here.
Sorry.
Welcome. Yeah.
Mm-hmm.
Okay, Ted. Can't hear you.
He's looking for his unmute button. I can see it on how his eyes move around.
Here. Why don't we go to Fred and come back to Ted? Go ahead, Fred.
Oh, yes. I just had one comment, Ole. Is the intention for having a universal option so that all future protocols of all types would use this one option? Or can it be expected that future protocols might define an option of their own, for example, to signify the fact that the protocol is in operation?
Yes, I don't think the intention here is to. I think the intention here is to let this, proposal live on its own, not preclude other uses of, that number space. Right? No,
okay.
it was not meant to, stop or deprecate or prohibit any other uses. It might be that, the discussion would come up. I think if you were to propose new configuration information options, or if it would be better suited or not to this format. But at least my intention was not to do that.
Okay, that's all I wanted to ask. Thank you.
Okay, Ted, do you want to try again? Not seeing you in the participant list. All right, let's try Dave Thaler.
All right. So I previously got in the queue and then dropped out because, Ole, you said the same thing as I was going to say, which was on the conflict question. Yeah, it's a configuration error, the same as if you would have included the same option twice, or if you had a conflict between DHCP and RA via any other mechanism, right? You already have to have some way of dealing with that on the host. Deal with it the same way. It's just another conflict, and you already have to have some conflict resolution. That's basically what you said. So that's why I dropped out of the queue before. I also was going to say, yes, I think I would support adoption of this one, and I would agree with Brian or whatever in the chat that says, yeah, and solicit implementations. However, this time I got in the queue to respond to Fred. I think it would be useful if the draft doesn't already to have some text. And again, I think Fred's text is it mandatory to use this instead of doing your own thing? And the answer is no. But at least you want to be able to provide some guidance, because I think what we've seen in the past is, as people create a new option, then a couple years later, somebody else comes along and creates it over in the other one. In other words, somebody creates an RA option and somebody else 3 years later comes along and puts it in DHCP, or vice versa, right? We've seen both of that, right? And so if you say that it's fine to create one and just as a new RA option and not put it under here, right, then the question is, okay, is that saying that this thing would be inappropriate for DHCP or whatever? And so you might want some text that says anybody that asks for something other than this should come with an explanation of why it does not make sense in DHCP or whatever, so that it would deter future presentations into this working group or into the DHC working group, as the case may be, whichever. So anyway, to just talk about, I think Fred's asked a great question, and I would like to see the draft cover and answer to it, but I think it doesn't need to be mandatory, as you said, Ole. So there you go.
Thanks. That's a very good point, Dave. Yeah, we will add that for sure.
Okay, Eric.
Just yeah, no hats kind of comment. A couple of things. One, there are some things that I think are nice about this. Among other things, there's some stuff over in Mask that's doing IP provisioning over HTTP quick kind of things, and they are potentially going to have to reinvent many of the same information control plane signaling stuff, like addressing and routing. Maybe this could be a way to head off some of the inevitable redundancy. But on the other hand, since Lorenzo is not here to make this comment, I'll try to embody him, I guess, for the moment. And that is, there are sometimes value in like not having certain things standardized, in the sense that this will allow or could allow networks to attempt to force clients to implement certain options, where if they had not been previously adopted by the IETF, they could reasonably perhaps have been ignored. This opens sort of an avenue for that to happen. This does not really apply to DHCP because the kind of networks that force clients to do things don't use DHCP, but they do use RAs. So there might be a Pandora's box aspect.
Yep.
That's all.
Yep. No, and I think at least we were, when we made this, regionally experimental, we were quite clear on the, that is this, aspect and of, removing process, and you can argue either way if the IETF acting as some sort of, blocker or police for, or guardian of number space is adds value or not, but yes, indeed, this would let that cat out of the bag.
Okay, Ted, last chance.
All right, let's see if this works.
Yes.
Oh, well, all right. So I would like to argue that this is probably not a good idea and that the working group should abandon it. And the reason I say that is twofold. One, it's always bad to have two ways to do something. It's always going to create interrupt problems. So at the very least, take out all of the stuff that's already in RAs. Don't have a way of doing that in this, right? If you have a way of doing that in this, then there's two ways to do it. Some people are going to implement it one way. Some people are going to implement it the other. You're going to have interrupt problems. That's bad. Second point, though, is that it's actually really a good thing that the IETF, and this is somewhat reiterating what Eric said. It's a slightly different reason. It's a good idea for the IETF to review this stuff. We don't want to have, again, multiple versions of essentially the same thing, and if you open it wide up, you're going to wind up with a train wreck. You're going to wind up with thousands of new options. Many of them will do the same thing as some other option. Some of them will be implemented by one vendor. Some will be implemented by another. You're not going to have interop. And the whole point of doing IETF review is to get interop. So I just really don't think that's a good idea. I mean, I think, had things been different, this would have been a better technology for doing what RAs do. So I'm not saying that this is a bad proposal from a technical sense. It's just that I think that it's going to have some really bad unintended consequences. And so I really would prefer to see it not happen, sadly.
Yeah. No, and you make a very good point, Ted, and I've certainly been, thinking the same thing. What I have seen, though, is that we sort of end up in these situations where, where half the IETF blocks the other half of the IETF doing something, and I'm not sure we necessarily should be in that position, or if the end results have led to a better internet or not, and so this proposal is really what happens if we step out of it and don't get in the way, and it might indeed end up in a train wreck, and then Jeff Houston gets to do that on another slide, and so that might be an argument for perhaps it should have been experimental. Still we moved it to standards track, right? Because that's a balance between implementers trusting this to be around for long enough that they can put it in implementations and use it. So yeah, sorry, I'll shut up.
Yeah, we're sort of over time, so we have Eric, Ted, and Torlis. Let's go ahead, but be quick. Eric?
I just wanted to say that to some extent, actually, I realize now that the encoding and the IETF review process are sort of orthogonal, right? We could adopt the encoding, but keep full IETF standards track review for the options until a future time, if we decided that we wanted to have a CBOR-based feature. That might address that concern.
Okay, Ted?
That would certainly make me happier, but I'm still a little concerned. I think the problem with if you open up the door, this is responding to what Ulla was saying. If you open up the door at all, closing it later is not really going to help much because you already have a problem. You could have an experimental space, but I don't know quite how you do that. So that's another way you could consider doing that. But I just, is this? Oh, the other point I wanted to make is we really, if we can't get important options through the process, then maybe the problem is the process, not the spec. And so maybe we should fix the process and not try to fix the spec by, Anyway, I'll shut up.
All right, so Torlis?
Firm believer that there is really no reason why we must stand on a one encoding of a functionality fits all, right? So the problem that Ted was mentioning before, that we may have different encodings and subset of vendors supporting one and other subset others, we already have that a lot through different features, right? I mean, look at the SRH header versus what they're doing in the IoT space, which is very similar and predates it, right? So I think this is a perfect experiment. I haven't tried to figure out what would be my reason to say standard on that, not, but experimental. I would very much encourage that.
Okay, thank you. I think being the chair for this, I think there is enough interest to do an adoption call, but I think if you object, we can have that discussion on the list and see where that goes. Okay, Brian. And also time-wise, so we are running behind schedule. And to the last two speakers on the agenda, I think it's likely we're not going to have time to do your presentations, but we'll see how long Brian's take. Go ahead, Brian.
Okay, that depends on how many questions people ask. So
yes,
this is an old story. This is an old story representing IPv6 zone identifiers in URIs or URLs. We discussed it last that I found in IETF 85, and we produced RFC 6874. The motivation, just to remind people, is that literal addresses in URIs are mainly intended for diagnostic type use. Sometimes there's a need to make tests related to using linked local addresses or a specific interface. So a particular Ethernet interface, a particular Wi-Fi, whatever. A web browser is sometimes the handiest tool for this. And in fact, there is a situation where it's the only tool you've got if you're trying to reconfigure a device that's come back for service, where the only way to configure it is through its web server interface, and the only way to reach that web server interface is through a literal IP address. if it happens to be a linked local address on a specific interface of your machine, you can't reach it if we don't solve this problem. And there is one application, it's an Apple proprietary application, but it's still quite widespread, I think, where they use linked local addresses over HTTP in a specific way that actually requires them to transmit the zone identifier to the other end and back, which you might think was not a good thing to do, but that's what they do. And if you go through the bug history on this particular feature for what is now called Firefox, I suspect it was called something else when the bug started, you'll discover there are a lot of people who want this. It comes up every couple of years or something. So why is this a fail? Why was the RFC a fail? Because of the percent sign. We know the percent sign is used for this purpose in the IPv6 stack because RFC 4007 put it there. If you type in a linked local address %F0 on a Linux machine or %7 on a Windows machine or whatever the particular names happen to be, it just works and it selects the appropriate output interface. In a ping command, we defined a mapping from that format into the URL syntax. Currently, no known current browsers support it. Actually, Internet Explorer still does support it, but that hardly meets the definition of a current browser. And the reason for this is that the browser community, which is embodied in a mailing list called WhatWG, they decided explicitly not to support this feature because they don't like it. There are three big problems with the RFC.
So, Brian, we have Stuart in the queue. Stuart, do you want to go ahead and ask your question?
I was just queuing up for later, but I can make my comment now.
I just
wanted to reiterate what Brian is saying. This is not an academic concern. I have a piece of network gear in my house that has a v6 linked local address, and I could not find any browser that would let me connect to it. And I failed to see why this was beneficial to me or anybody else.
Okay. Well, by the way, since I hear you, do you want to join this draft as co-author? Because we put you in as contributor so far.
Yes, I'm happy to do that. I did see the emails fly by over the last few weeks. I just didn't get around to responding. I've been busy, but yes, I would like to help solve this problem.
Okay, cool.
Good.
So the three problems with 6874 are that the %25 is needed according to the RFC because the URI syntax requires you to encode a percent sign, since a percent sign in the URI syntax is an escape character, which means you can't cut and paste from a ping command into a URL. There's one belief system that says it's required because the percent sign is always an escape character in the URI. And there's another belief system that says if you write your BNF properly, you don't need that percent encoding because you can simply specify that that particular bit of the URI is not percent encoded. Okay, our proposal in the draft at the moment is to not change that, but that's open for discussion, probably not today. The second big problem with RFC 6874 was that it has a rather strange requirement, which is to require a host to delete the zone identifier from an outgoing URI. That's within the HTTP host header. I actually dug into the HTTP RFC for once in my life, discovered that this requirement actually violates the normal behavior of HTTP. At the very least, it's awkward to code, and it breaks at least one application that we know of, which is CUPS. So our proposal in the draft at the moment is to simply delete that requirement because it's never going to get implemented anyway, and it's one of the main reasons that the browser people don't like the RFC. Second, the third problem is somewhat similar. We also have a rather screwy suggestion in the RFC that parsers should support the %25 encoding of the percent sign, but heuristically accept ones that don't include it. So the famous %F0 would be okay. If you happen to have an interface, an internet interface called, I think %EE is one of the ones that wouldn't work. That wouldn't work because %EE would decode as a URI into some other character rather than, so you'd have to put %25 EE in. The heuristic code to get that right is really not trivial. It's also very confusing to users. So the proposal in the draft is to throw away that heuristic. So really the most important slide is the last one. We need feedback on this from IPv6, of course, from here and from operators. Would they really want to use it? If it was in the browsers, I think Stuart just gave an answer. We need feedback from the applications area of the IETF, which is why we took this to their area meeting a couple of days ago, or was it only yesterday? And we need feedback from W3C, who in some sense own this space. And we need feedback above all from browser implementers, including the working group people. So unless we're told to shut down today and go away, I think the next thing we would probably do is try and start this dialogue with the outside world, as well as continuing to discuss the draft on the 6-man mailing list. And that's where I'll leave it and see what people have to say.
Stuart?
Question now, but not for Brian, for everybody else. When we did the original RFC, I was one of the people advocating just not doing any % escaping for that part of the URI, because it's a V6 literal, it contains hexadecimal and colons, and there is no need to escape it. And the only argument to escape it is, well, we escape everything else, so why not escape this? And one downside is you can type a ping command and ping the host and get a reply, but you can't copy and paste that address into a web browser. It requires some manual editing, which is hard to explain. And as we've seen in these slides, the escaping or not escaping, or having heuristics because it might be escaped or might not, also comes with a lot of pain. So I'm interested in hearing from other people who would support the idea that that thing within the square brackets is exactly the same as a V6 link local address used on the command line with a ping command or anywhere else you would use it, rather than being different in a web browser. I guess I should give people time to think about that. If there's any immediate reaction, I'm happy to hear it. If people want to ponder that.
If Dave Taylor's still here, he might comment, because it was he who pointed out that this is used internally in Windows with the %25. I'm wondering why that decision was taken up over in the Windows department.
So sure, I'll jump in just because you asked me to comment. I don't remember the technical details that I had when we first described it, because I probably had some specific anecdotes then that I don't recall now because it's been a while. But there's a lot of URI parsers in the world. There's lots of pieces of software to do that in operating systems and middleware inside applications and things. And so the %25 is probably the only thing that's safe given the wide deployment of URI parsers all over the place. Yeah, it prevents cut and paste, but you can make it work for a specific implementation, but putting it in a standard issue is just going to break applications. I think the argument went something like that. I can't comment on specific things without looking stuff up if you have any questions about that. But
and this has changed, by the way, between Internet Explorer and Edge, because Internet Explorer still supports it and Edge doesn't.
Yeah. Yeah, that's because Edge switched to, if I remember right, Edge switched to use Chromium as the underlying implementation. And so it probably inherited whatever Chromium did. But the point is, there's many different URI parsers in browsers and outside of browsers. Applications that do things, middleware that does things, middle boxes that do things with URIs, and so on. So it's really hard to make any change with URIs, given that they're so prevalent all over the place. And of course, 6874 did make a change, and what you've seen is that it didn't work with everything. So.
Yep. So I think that we really have to get some feedback from the what working group people.
Yes. So we're just about out of time, but Torlis.
Yeah. Sorry, the last thing I was mentioning is that I'll put it in the chat then.
Good.
I mean, would as a user, would I like something consistent? Sure. Would I like something consistent that's ugly? No. So, I mean, isn't there any way that how we can find another character that doesn't have to be escaped instead of %25? I mean, this is not going to go away anytime soon. So even if it takes a little bit longer to get it proliferated, I mean, why not do whatever is the nicest that can be consistent instead of, this stuff, yeah.
The problem is RFC 4007 set this in stone a long time ago, and it's in an awful lot of IPv6 stacks in the API, at least the socket API.
That's fine, but I mean, we can always extend that. We don't have to replace what we already have. We just,
You ever tried getting something changed in POSIX? It's really not easy. It's probably harder than getting something changed in the URI parsers.
Well, do you think that you really need to go through POSIX to get adoption in the industry? I'm not
So
sure.
I'm going to put my chair hat back on, not as a co-author here. So we are out of time. My take, Oli should confirm, I think there's interest in doing this. I think there's clearly some questions about what the right course is, but this should certainly be socialized in other places, as Brian suggested. But I think we can, I'm not, so this should continue on the mailing list. But I do think what we have now is clearly broken, and we should try to fix it the best we can. Okay, so we are out of time officially. My understanding is that the Meet Echo will keep going for a little bit. We have 2 more speakers on the agenda. If you can, we can try, if you want to go forward, we can do if you can do it in 5 minutes or less with no questions. You can go ahead. So, Valchenko, Edward.
Decided that would be Polo from our side.
You should get the slides up now, Paulo.
Yeah, Polo.
Says it's been shared.
Second icon, push second icon. Preloaded slides.
Yes.
There we are.
So hopefully you can hear me.
Yes, go ahead and be quick.
Right. So very quickly, I go directly to say the most important slides just to explain what our draft is about. So basically, we are trying to analyze cases of prefix invalidity and try, of course, to propose solutions for those cases, looking in particular to multi-homing, multi-prefixes environments. In the presentation, you will find much more information. I simply skip the slides for the sake of saving time. So basically, what we are trying to achieve is to solve a case such as the one represented in the slide here. So basically, we have, for example, a home or a office network with a couple of routers connected to 2 or even more, possibly, upstream providers, and suddenly one of the routers fails or has a connectivity issue. So the problem is how to cope with a situation where you have that router still working and presenting itself to the default router or the next hop for a set of prefixes that have not been deprecated because they have not been invalidated because of the situation represented here. So the diagram on the right simply represents the case. So what happens with, let's say, having one of those prefixes which becomes suddenly invalid, but one of the hosts sitting in the net is not able to understand that or does not have the means to understand that. So it keeps on using the same prefix to build a source address. The draft is clearly much wider than that. I simply show, probably as one of the final slides, this summary, which provides on the left possible solutions to the different issues that we may find. Speaking of prefix invalidity, on the right, let's say the proposed extension or modification to a set of already available RFCs, specifically considering neighbor discovery, so 4861. There are other proposals, but let's say this is the core of our analysis. So we are not touching, for example, timers, as other drafts are proposing. That is the main, let's say, content of the draft. And I conclude with slide 8, just to share with you that we would be happy to receive comments, contribution, even criticisms, of course. We have produced the draft 0, so it's quite new. We uploaded, I guess, a couple of months ago.
Okay, well,
contributions are welcome.
Thank you very much. Please bring this to the mailing list. Okay, and then Jaidong, can you share your slides?
There we are. Please go ahead.
Thanks for the time. This topic is about carrying the VTID in the IPv6 hop-by-hop extension header. Okay, here are some background. I will skip it. Basically, we will define a VTN identifier in the packet header, which can be used to identify the set of resource allocated for the per VTN packet processing. And this is analyze some options in the packet header to carry this AVT information, and the result conclusion is it is better to define a new IPv6 hop-by-hop option for this special purpose. This is the format. I will skip it. And this is the procedures. It is describing the draft, and we also skip it. Okay, this is updating the recent versions. We have the new co-author GM, and we clarify this is an option in the hop-by-hop header. We also clarify that VTN ID is only used to determine the set of resources for the packet processing. And we also added some operational considerations to reference the hop-by-hop processing draft. Okay, so in conclusion, this document proposes a new hop-by-hop option for the hop packet forwarding treatment, so it aligns with the designed functionality of the hop-by-hop header. The content of this document has been stable, so we'd like to confirm whether the document belongs to 6-man working group. If so, and we'd like to ask for the adoption on this document. Thank you.
Okay, well, thank you. And like the previous one, please discuss this on the mailing list.
Okay.
So thank you.
Thank you.
So we have completed about 8 minutes over schedule, but I think we've had a very constructive discussions on a variety of topics. So I think Oli and I would like to thank you very much, and I wonder if we're going to see you in Madrid or on the computer again next time. So good. Thank you all. See you on the mailing list.